Okay, good afternoon, good morning, everyone. First of all, I'm happy to be invited to this talk. I would like to thank SRD for this invitation and also Rexon. In fact, I have to confess that this is the first time I learned of this society, SRD, even though I have worked with Rexon for quite a number of years. Yeah, but it's a good opportunity for me. Back in Singapore, okay, I am a mathematician by training, and my work involved mathematics education, in particular the professional development of mathematics teachers. So that's why the title that I can only talk about is on maths education, and of course I append innovative practices in mathematics education. I will share with you some insight. I will present to you some general overview of the practices, of the recent practices in maths education. I will not go too much in depth. So I will talk about the recent trends of innovative practices in maths education, focusing in particular on teachers' professional development. And of course, another new trend in maths education is the computational thinking in mathematics. Computational thinking is an independent subject, but in mathematics in particular, when you infuse this in mathematics, it gives mathematics another flavor, which I will elaborate in a while's time. And of course, another trend that we see in recent education scenario is the infusion of the pop culture for mathematics instruction. And of course, we also see trends in innovations in classroom practices. I will share with you some of these ideas very briefly. So in 2022, which is this year, I had the opportunity to co-edit a volume of the proceedings of the Singapore National Academy of Science, and the theme was on innovative practice in maths education. Rather than seeing myself as a co-editor, but I really learned a lot from all the experts in maths education around the world, and I had a glimpse into the trends of the most recent development, and some of them are really new to me, which I am really very impressed. And of course, with my reading up of the current existing literature, there are a lot of interesting things. So in particular, some of the trends that were reflected in this latest edition, which reflects the contemporary state of art of maths education practice, focus on these few aspects. Teacher professional development. This is a big area which has received attention. I believe most of Rexon's work is on teacher development. Yes, and a lot of things involve teacher professional development are taking place. A lot of changes, a lot of new directions. And also the next thing is the use of technology has changed the way the classroom lessons are being enacted. This technology, of course, follows up with the infusion of computational thinking in mathematics. Back in Singapore, even though it is a local thing, but I believe worldwide there is a trend to infuse mathematics, to infuse computational thinking into mathematics. And this is in preparation for data science and beyond. Other more, or rather less orthodox things involve infusion of pop culture. It actually received a lot of attention recently, even though I believe in countries like Japan and Korea, this is quite common. And of course, classroom practices, the last point, also receive some attention. I will briefly share with you some of this trend. And in fact, each of these points, I could take 1 hour to talk on it, but I would rather not do that. I will introduce to you the general trend. The first big thing is on teachers' professional development. I believe many speakers, I think in your field, you also talk about professional development. And in the field of education, or maths education in particular, we have this trend of a shift in paradigm in teachers' professional development. In the past, whenever we feel that a teacher is lacking in something, they will attend some workshop to hopefully to top up their knowledge in that area. This is what we call the deficit model. That means you realize that, for example, a school leader realizes that the teachers are not so good in maybe classroom discipline. Send the teachers for workshop, maybe 1 day, 2 day, or 3 days workshop, and come back. And hopefully by then they are expert in this area. It seems that the recent trend is moving slightly away from this. So that is this one-off workshop. Not that they are irrelevant, they are still there, but they are giving way to something more nurturing, which is a longer-term professional development to develop their professional growth. For example, after attending a one-off workshop, teachers are guided by their so-called mentors for a period of time in the school, where they really put what they have done, what they have learned in the workshop into practice and in regular consultation with the mentors. The mentors are those who come from the teacher training institutes. So this is what we call the growth model. So many of the researchers now in teachers' professional development have moved away from the so-called deficit model, that means top up whatever that the teachers are lacking, to a growth model. That means you hold hand in hand with the teachers to make sure that they grow from zero to the maximum point that you want them to achieve. And this takes a long time, and a lot of study has been done on that. And there was an interesting paper in this research that actually talks about tracking the learning trajectory of teachers. In fact, from beginning teacher to experienced teachers, this is even more ambitious. This is not a one-time PD course to finish now. They chart out a learning trajectory for a teacher from the beginning phase. Beginning teachers means after they are qualified as a teacher, all the way to an experienced teacher. So this is one of the trends that's seen. The second trend in the innovative practices is the computational thinking itself. And computational thinking is infused in mathematics. Okay? You see, infused in mathematics, does it mean that it's going to change the whole paradigm of mathematics? I would disagree. I would not say so. In fact, with the infusion of computational thinking into mathematics, it actually brings the mathematics community more aware of the fundamental of mathematics. That means why you teach mathematics. In fact, in most countries of the world, the fundamental of mathematics is problem solving. You teach your students algebra, geometry, differential calculus, all this for what? Eventually, when they go out to the world, they must be able to solve real-world problems, unless they become academic. You see, nobody would remember how to solve a system of n by n equations unless you are an engineer. But certain things that you have acquired in the mathematics learning process stays. That is the fundamental problem solving skills. So, in fact, computational thinking is the foundation of efficient problem solving. So the next point over there that I say is that in mathematics, mathematicians actually have two types of proof. One type of proof, which is what we call existential proof, to show that something exists. Okay, but unfortunately, when you show something exists, you may not know how to find it. So you need to have another aspect, which is the constructive aspect. And this actually leads on to computation. It is interesting. So in a way, computational thinking is the balance of the two aspects of mathematics, and to help us refocus back on our foundation of mathematics, what we teach mathematics for, which is fundamentally for problem solving. Okay, of course, there are new trends like computer-based modeling. All these things are receiving attention. And of course, as part of computational thinking, it will be of added advantage to students when the students learn some coding. Always bear in mind, when it's infused in mathematics, when we teach students certain aspects, for example, a new programming language, our task, our objective rather, is not to teach them as many programming languages as possible. Once a student came to me, told me that he learned a few types of programming languages, Python, Basic, and all these things. But from the mathematics perspective, it is not the more the merrier. It is the thinking underlying it that is important. So in other words, if you do not know a programming language, but I give you a code, you understand what this code is used for. Are you able to modify it? You see, it's not everything starting from scratch. It's this sort of mathematical thinking that is very important for computation, and which is actually afforded by mathematics. Okay? In fact, for classroom practices, we see many teachers are using the most affordable things that they can do. For example, the spreadsheet, Microsoft Excel. Most schools today may have the computer lab, and Microsoft Excel is the first step. Many things can be done using that. Okay, I will not go more in that. I will just stop over here for this part. And of course, other aspect, the use of technology has also altered our paradigm of teaching. I give you an example. For example, geometry. If you ask a pure mathematician, geometry is about proof, or the deductive proof. But with the use of technology, it is not, the first thing that you teach students is not the deductive proof, but how you transit from intuition to experimental and eventually to deductive reasoning. So